My name is T. Shikreddy from CSCP, and my roll number is 229518057, and my AAT topic for the data structures is T-structured programs. So let's get started. So basically, let's first learn what is exact meaning of data structures. Or we can say data structures means the raw facts and figures, means the facts or the figures which is not modified or which cannot be modified, or we basically get the raw facts and figures into data structures, DS. So let's get it. This is the basically tree structured programs in data structures. So first, introduction to trees. First overview of trees. Trees are fundamental data structures used in computer science. They are used to represent hierarchical relationships between data, such as parent-child relationships or containment relationships. Trees have many applications in computer science, including in algorithms, databases, and artificial intelligence. Basic tree terminology. Node. A single element in a tree, root, the topmost node in a tree, parent, a node that has one or more nodes. Child, a node that has a parent node, leaf, a node with no child nodes. Subtree, a tree that is a distant of a node. Height, the length of the longest part from the root to a leaf node. So overview of trees means what exactly the trees means. Trees, what exactly tree structure program means. So overview of trees. And then trees are a fundamental data structure used in computer science. They are used in represent hierarchical relationships between the data, such as parent and child relationships or um, containment relationships. Trees have many applications in computer science, including algorithms, databases, and artificial intelligence. And a tree that is descendant of a node, height, the length of the longest part from a leaf to a node, from a root to a leaf node. Next, that introduction to tree structures. So, what exactly the basic of the tree structure mean? Tree structures are an important part of the data structures and algorithms. They are widely used in computer science and has various applications, including storing hierarchical data, searching and sorting. In this presentation, we'll cover the basic of tree structures and the different types. So, the tree structure programs are mainly used, like included in storing hierarchical data, searching and sorting, like different types of sorting techniques like bubble sort, etc. Bubble sort, merge sort, quick sort, and insertion sort, etc. And in this presentation, we'll cover the basic of tree structures and different types. So the following are the different types of tree structures or first one is the binary tree, next balanced tree, red tree, and heaps, tries, B trees, avial trees, red black trees, and splay trees. So first applications of this, what how tree structure programs are used, where they're used, in which type of programs they can be used. File systems. File systems are often implemented using uh, tree structures. Direct Directories and subdirectories can be represented as nodes and their contents as children. This allows for efficient searching and retrieval of files. Database indexing. In database, indexes are often implemented using tree structures. This allows for efficient searching and retrieval of data based on specific criteria. Next, compiler design. In compiler design, syntax trees are used to represent the structure of the program. This allows for efficient parsing and analysis of code. So, these three file systems, database indexing, and compiler designs are applications of this, like compiler design. In compiler design, syntax trees are used to represent the structure of a program. This allow for efficient parsing and analysis of code. Next, tree structured programs in DS. So, what is exactly the meaning of the tree structured programs in data structures? So here is the diagram for the representation of the tree structure on the in the first and the second figures. First, file system in tree structures. Tree structured programs are used in file systems to organize and manage files and directories. So tree structured programs in DS are used to mainly used for organizing and managing the files or the data and the directories. Next, database indexing tree structures. Tree structure programs are used in database indexing to efficiently search and retrieve data from large databases. So, in database indexing, tree structures are mainly used in databases indexing to efficiently search and retrieve data from the large database. So, they are mainly used for retrieving the data from the large databases or the retrieve the data which are lost. Not exactly the lost, but the retrieve data from the large databases. Next, compiler design tree structure. Tree structure programs are used in compiler design to parse and analyze source code and generate machine code. So, in compiler design tree code, the compiler designed to parse and analyze it first analyzes the source code and generate the machine code. So, basically, here the compiler generally to parse and analyze the source code and generate in the machine code. Next, binary trees. So the first tree structure program is the binary trees. So what exactly the definition of binary tree is that a binary tree is a free data structure in which each node has at most two children. So in binary trees, each node has exactly two children as at most two children, referred to as the left child and the right child. Next, operations of the binary trees. Binary trees support operations such as insertion sort, deletion sort, and search sort. In a binary search tree, the left child of a node contains only values less than that of the node's value, while the right child only value greater than that of the nodes. So binary is something but which has in which each node has at most two children or which is divided into at least two things or the two children referred to as the left child and the right child. Next, the other tree structure program is balanced tree. For the first, what are balanced trees? Balanced trees are the type of data structure in computer science that are designed to keep the tree height as small as possible. This helps ensure that the tree operations such as searching, inserting, and deleting are efficient as possible. So, in balanced trees, it is used to keep as small as the tree and make sure that it ensures a more efficient process for the insertion, searching, and deletion process. Next, types of balanced trees. Avian trees, a self-balancing binary search tree that maintains its balance using rotations. Red-black trees, a self-balancing binary search tree that uses a color scheme to maintain balance. Splayed trees, a self-adjusting binary search trees that moves frequently across nodes closer to the root. Next, heaps. Heaps, what introduction for the heaps is something, but a heap is a specialized tree-based data structure that satisfies the heap property. It can be visualized as a binary tree with two additional constraints. So, a heap is a specialized tree-based data structure that satisfies the heap property. It can be visualized as a binary tree with the two additional constraints. Next, types of heaps. So we can have there is a different types of heaps. First one is the binary heap. A binary heap is a complete binary tree where the parent node is always greater than or equal to its children. So binary heap is complete binary tree where the parent node is always greater than or equal to the children. Next, Fibonacci heap. A Fibonacci heap is a collection of trees with a minimum or the min heap order property. Next, binomial heap. A binomial heap is a collection of binomial trees that satisfy the heap order property. So, binomial heap is nothing but is a collection of a binomial trees that satisfies the heap order property. And the Fibonacci heap is a collection of trees with a minimum order property. Next, tries. What exactly the definition of tries is nothing but a trie, also known as a prefix tree, is a tree data structure that stores a collection of strings. So tries or the tree tries, also known as a also known as a prefix tree, is a tree data structure that stores collection of strings. Each node in the tree represents a string or a prefix of a string, and the edges represent the characters that make up those things. Tries are often used for efficient string searching and retrieval. Next, what are the advantages of exactly tries? Fast search and retrieval of strings, memory of efficient for storing large collection of strings, allow for efficient prefix matching. So exactly what tries or the trees mean is that it is a prefix, is also known as a prefix tree. It is a tree in a data structure which stores the collection of strings. Each node in the tree represents a string or a prefix of a string, and the edges are the characters of that make up those strings. And the advantage of the trees or the tries is nothing but allows for efficient prefix matching, memory efficient for storing large collections of strings. Next, fast search and retrieval of strings. Next, what are B trees? What exactly B trees means? Definition is nothing but a B tree is a self-balancing tree data structure that maintains sorted data and allows such as sequential access, insertion, and deletion in logarithm time. So, what exactly B tree is nothing but is self-balancing tree data structure that maintains sorted data. Means that data in the B tree is always sorted and allows the such as like insertion, sort, and deletion in efficient manner. And the properties of B type is nothing, B tree is nothing but B trees have the following properties. All leaves are at the same level. A B tree of a order M has the following properties. Every node has at most M children. Next, every non-leaf node except root has at least M by 2 child nodes. Next, the root has at least 2 children if it not a leaf. Next, avial trees. Overview over avial trees, nothing but avial trees are self-balancing binary search trees that maintain a balance factor for each node. The balance factor is the difference between the heights of the left and right subtrees of a node. AVL trees are named after the inventors Adelson, Welsky, and Landis. They were the first dynamically balanced trees to be proposed. Next, operations for the AVL trees. The operations on AVL trees are similar to those on the binary search trees, with the added functionality of the maintaining balance factors. Insertion and deletion can cause an imbalance in the tree, which can be corrected by the performing the rotations. Next, red black trees definition. A red black tree is a self-balancing binary search tree that uses a color scheme to ensure that the tree remains balanced even after insertion and deletion. The color of each node is either red or black, and the tree is balanced such that no part from the root to a leaf is more than twice as long as any other part. Next, insertion. When a new node is inserted into a red black tree, it is initially colored red. The tree is then rebalanced using a set of rules that ensures that the tree remains balanced. Those rules involved recoloring nodes and performing rotations on the tree. Next, deletion. When a node is deleted from a red-black tree, the tree is rebalanced using a set of rules that ensures that the tree remains balanced. These rules involve recoloring nodes and performing rotations on the tree. In some cases, extra nodes may need to be added or removed from the tree to maintain balance. Next, splay trees. Advantage of splay trees are that fast access for frequent access elements and self-adjusting to access pattern, reducing the need for the manual balancing. Disadvantage higher overhead due to additional operations required for splaying nodes. And overview for the splay trees are self-adjusting binary search tree that adapt to the access patterns of elements quicker to retrieve. Splay trees achieve this by bringing the access node to the root of the tree through a series of rotations and other operations. So conclusion, tree structures are an important part of data structures and are used in many applications. They provide efficient storage and retrieval of data as well as easy manipulation. Binary trees, balanced trees, heap trees, red-black trees, P trees, ABL trees, and splay trees are all examples of tree structure that have different characteristics and are suited for different purposes. Understanding the strengths and the weakness of each type of tree structure is crucial for selecting the appropriate one for a given application or the question. Additionally, the study of tree structures is an ongoing field of research with new developments and improvements being made regularly. As such, it is important to stay up to date with the latest advancements and techniques in this area. So yeah, thank you. And this the AET Tech Talk topic, tree structure programs for data structures. So yeah, thank you.